Hello, everyone. I hope this email finds you well. We are thrilled to announce that our Chrome extension has been officially approved by Google and is now available on the Chrome Web Store. You can search for Causation Catalyst. This is a Chrome extension that actually lets you upload a CSV file and calculates a full regression analysis for linear, quadratic, and exponential regressions. So you get those three correlations calculated, and then you get the correlation factor based on the regression of your data. And then, as you already know, correlation doesn't imply causation, so it's also good to know, what the causation factor is, and just to make sure that the data that you're analyzing could be correlated, but one variable does not necessarily have to cause the other one to move, or vice versa. So yeah, we are making a post here, and some of the key features is you get instant data analysis, the the correlation coefficient calculator can determine the strength and direction of the relationship between the variables. So, for example, in this set of data, the correlation, it's pretty obvious. It's a linear um, correlation close to one, right? And that's what you're gonna get on the result. The linear regression gives us 0.99 for this particular set of data. But you can also get the quadratic regression and an exponential one. And obviously, the best fit for this example is the linear regression, right? But let's see how it goes, how it works. I have the extension. All you need to do is go to Chrome, search for Causation Catalyst, and then you can install the extension on your web browser. And when you're here, your CSV file, the one that you're gonna upload, has to have just those two variables. And you can do, let's see, downloads, documents. Let's do list of data, and then downloads. I have a few test files here that I can use. So let me do this one. So I exported a file, and you'll see it will tell you how many records you were successfully uploaded. And as you can see, my headers are, there are no headers actually in this data. So your data can either have headers or not. So in this case, it's actually taking the first row of data as headers. But so keep that in mind. If you want to see a specific variable name displayed on the charts, your data should have, the first row should contain the names of the variables, right? And then make sure that your data is just numbers, either decimal or row numbers. No commas, no dollar signs, no symbols, nothing. Just numbers, integers, and decimals. That's it. Otherwise, you may get no data successfully imported message. So if you have two variables that you want to compare, and as long as it's, again, decimals and just numbers with no commas or anything like that, no dollar signs, anything, just data, you can then just click the regression analysis. You're going to get a preview of the formula that best describes a linear regression, the formula that best describes a quadratic regression, and then last but not least, the formula to get the exponential one. But it will also tell you which one is the best fit. And then it will give you a brief interpretation. Like in this case, the best fit is the linear model, right? But it suggests a strong positive correlation between the variables. So you click OK, and it's basically telling us that the linear regression is the best fit. Then you can calculate the factor, which in this case It says a best fit regression model shows a strong negative. It's a strong negative correlation between the variable, and that's why you have minus 0.98, meaning the data is negatively correlated. So they don't correlate at all, right? But even then, so this suggests that 96.4% of the variance in Y could potentially be explained by the model, right? So it's really, they don't correlate at all. But furthermore, remember, correlation doesn't imply causation. So you still need to run the causation analysis to determine whether this correlation coefficient it's actually meaningful in a way. And in this particular case, the negative correlation it's definitely caused a very strong coefficient of 0.96. So again, if you read the entire interpretation, you'll see the best fit regression model shows a strong negative correlation between the variables. And then this suggests 96.38% of the variance in Y can be explained by the model, right? And then remember, correlation doesn't imply causation. Furthermore, investigation is needed for any causal relationship. And then when we search for that causal relationship, we find that the error squared of 0.96 suggests that 96% of the variance in Y can be explained by X. So in this case, there is a negative correlation that it's definitely caused by the movement of one variable versus the other. In this case, Y can be explained by X negatively, in a negative way. And then at the end, you can actually, just read through all the details, all the analysis, your data, the chart with the linear regression, and then at the end, if you want, you can also export an executive summary of all your data and the results. Should you wanna, export that executive summary, it will display the analysis results with the formulas, all the analysis and the interpretation, and the raw data that you entered to analyze, this particular set of records, right? And that's it. Feel free to give it a try. Causation Catalyst. It's available on the web Chrome store. And let us know if you have any question. Look forward to it.